Hi, in this video we are going to see how we can define a new board in Ardupilot code. I will demonstrate how to add or define the OBAL board, but you can use this as a generic sample of how in general you can define your own board. So let's first see what we want to do, then we will see how to define it in Ardupilot code. First, we have a Raspberry Pi board. This Raspberry Pi has IMU 9250. This IMU has a gyrometer, accelerometer, and magnetometer. It actually has a MBU 6050 and a magnetometer. And it is connected via SPI. Then we have a barometer BMP 180, and it is connected via I2C. And then there is a PCA 9685. This is a PWM generator that is used to generate output for the motors. And here we have ADC analog to digital converter that is used to measure the voltage and the current of the battery, and it is also connected via I2C. So we have three devices connected via I2C, ADC, BMP, and PWM, and we have one SPI device, which is the IMU. We also have other ports for RC input, and we have ports for LEDs. We need to translate this to Ardupilot code so that when we compile this Ardupilot code and run it on Raspberry Pi, it will be able to control these sensors. Okay, here it is, the Ardupilot code. We will change some files. These files are the files that you need to access in order to define your own board. For sure, if your board is more complex, maybe you will need to access more files, but these files are covering already most of the things you will need to define a board that runs Ardupilot. First, we need to define a definition for the board. Here in C, we will need to make a define, and we can give it any name. There is a code style and a naming convention, so we will define it HAL board, subtype Linux, and then you add your board name. Let's open this in, here it is. You define your board name with a prefix HAL board subtype Linux, because it is a Linux based board, and then you give it a number. As you can see, it is in sequence. Good. The second thing is to go to this file. This file is Linux.h. Linux.h exists in libraries abhal/board. This is the most important file. At least in my opinion, this is the most important file because you are going to define the sensors that you are going to use. Let's go and check this file. First, we have some definitions, some macros. These macros are important because you will use some of them in order to add your sensors. And after this, you will find that there are some definitions of all the boards that exist that runs on Linux. If you go here back to this file, every definition here is used here. Let's choose anything, for example, BXF mini. Here it is, and here it is the definition of the board. Now let's go to OBAL. Okay, here it is, a definition of the board. Like that. In OBAL, I defined a major type or major subtype called OBAL version 1. And because I plan to use different sensors, so I choose to define a subtype called MBU 9250 SPI. So this board is using this sensor. That's why I give it a subtype called MBU 9250 SPI. Okay, regardless of this definition, you need to define here some important things. The first thing that you need to do is to define the location of the directories for log, for train, for storage, and the default path of the param. This file is used as an initial setting for the board. You can see that in the video of how to install OBAL board software on Raspberry Zero, you can see that we defined this file and we defined some values in it. Next, we will define the sensors that we are going to use. As I mentioned, I am using MBU 9250, so I defined here that I am using MBU 9250 and it is connected via SPI. This is how you defined it. Then, as I mentioned also, that this sensor contains a compass, a magnetometer, and this compass can be accessed using SPI as well. So, and it is connected and it is accessed via the 9250. So to define this, I defined a magnetometer which is AK8963, and it is accessible via this MBU 9250. You can check the data sheet to see how they are connected and how you can access the compass via this sensor. Then here I used the barometer and it is connected via I2C. So here I define the barometer and it is connected via I2C and it is PMP 085, which is compatible with the PMP 180. That's why I use this name. And here I give the I2C address of the device. You can add extra compass, and in that case you need to define the compass and the I2C address. But actually this compass Ardupilot can automatically identify it, so there is no need to define it explicitly. So in this file, this is the most important section. When you define the board, you define the sensors that you are using in this board and how they are connected together. We can check here. For example, let's see BXF many, for example. Okay, they are using almost the same topology. Actually, OBAL was a very so in BXF many, you can see MBU 9250 connected also using SPI, and there is a baro, but this time baro is connected via SPI as well, and there is a magnetometer that is connected via SPI and should be accessed via MBU 9250. These are the LED pins. Let's go here to OBAL and see. These are the same definition, the LED pins. Let's check here 27, 22, and 4. So we go here. This is the pin number, not the GPIO number. So if we go to this screen that translates the GPIO number of the LED 27, 22, and buzzer is 12, and here LED 3 is GPIO 4. So it is 4, 22, 27, and 12. Let's check here. 4, 22, 27, and 12. Again, you need to tell the board that the on state of the LED is 1 and the off state is 0. So when the board wants to turn on the LED, it will raise the volt to 5 volt and or 3 volt, whatever the configuration of the GPIO pins. And when the board wants to turn it off, it will output 0 voltage. So you can inverse this logic if you want. Okay. Again, this is the most important file. This is another file here. This file, which is util RPI. Here you want this file contains some helper functions that you need to use with Raspberry Pi. So I want to include it in my code. So I need to add the subtype of my board that I originally defined it in here. It's becoming complex. Okay, here ABHAL boards. I defined it here. Okay, so I need to include this definition in order to include this file with me in the compilation. Let's close these files. Another thing is that because I defined the SPI here, this SPI needs some extra definition. So I need to go to this SPI device, play it in a more clear way. So this file, you need to define that you are using which mode of SPI, and you need to define the select chip pin and the speed. The select chip pin, here it is. Here it is, SPI chip select 0, SPI chip select 1. I can specify here a GPIO, but I left it as the default, and the default is this pin. And this is the speed of the bus that of the SPI that I want. So in this case, after defining or writing these lines of code, the SPI is now accessible. I defined the SPI using 2 steps. The first step is that I added the drivers and defined the sensors. Then I defined the chip select pin, and I defined the speed of the SPI. So now we finished SPI stuff. For I2C, you only need to add this line to define the borrow. So there are no extra lines you need to add for I2C. Okay, let's move to another file. This is the next most important file. Okay, let's first compare it like that. Okay, here I added the definition. Let's take this code and only. Okay, so I also added the definition of the OBAL port here, so that the RPI utility functions are included. under the name of util instance. You remember that I already also activated this part of code by adding this definition, so that this part of code is included. So now the util RPI contains a code, and this code is now I instantiated an instance under name util instance by adding this definition. Now I want to add my analog to digital converter. Analog to digital converter here is there is a driver already for it, which is ADS 1115 as analog in. So I added my definition part so that I activate this line. So this line is this chip that I use for sensing voltage and current. That's it. For battery, we need to define again the definition of the board, OBAL board, and here we will define which pin in this, okay, which pin here is going to be the voltage and which pin is going to be the current sensor. So we define this from here, and we define the default voltage divider and ampere divider, and these settings can be changed from the mission planner parameters. Next is the GPIO RPI. This I need to get access to GPIO pins or ports, so I added my definition here also, so that GPIO are included. Okay, next we want to use the RC input. The RC input, again, we are using native driver. So this driver is called RC input RPI, and we need to activate it. Let's go to this driver. This driver has some definitions we need to define. We need to define two things: the total number of ports that we want to use, which is 8 here, RC1 till RC8, and we need to define these GPIOs numbers, which are here: GPIO 5, 6, 13, 19, 26, 21, 20, 16. Okay, so the total number of channels, we define it here in RC input RPI.h. But here again we activate this file, and here we define the ports that we use. Let's get a clear view. Here it is. Here we define the signals, high and low, 0 and 1, and we define the pin numbers, GPIO numbers, GPIO 5, 6, 13, 19, 26, 21. Let's check it. 5, 6, 13, 19, 26, 21, 20, 16. Okay, 20, 16. You can notice the order of defining these ports equivalent to RC1, RC2, RC3, RC4, etc. That's all you need to define in this file. By the way, this file also accepts not only PWM but PPM, but here I am using PWM, so I'm using 8 different ports. Okay. GPIO, we only activated the files by adding the definition. Let's go back to this file, Linux. Okay, so we covered RC input, we covered RC output. RC output here, as I mentioned, it is a chip BCA 9685, which is this chip. This chip is accessible via I2C, and it has a chip select pin, and this chip select pin is connected here at pin 11. It is connected via this circuit, but it is connected indirectly to this pin. So let's go here. Luckily, the driver of this chip already exists in Ardupilot, so you don't need to write any extra drivers. You just define the driver as RC output driver, and then you define the address, and this address this chip can have different addresses by soldering some pins together. You can change the address of this chip. So that's why it takes the address as input, and this is the GPIO 17, which is this pin, which is here 17, pin number 11, which is pin number 11, servo enable. Next, we need to define some notification. The notification here are the LEDs and the buzzer. As you remember, we already defined the GPIO number of the heads of the LEDs and of the buzzer here. But what we want to do here is to select the driver that will use this LED. So we're going to use a LED-based notify board, and then we can choose between different LED boards. Actually, we can choose between a board LED 2, and there is another board here in APE notify. Which is board LED without number. This board LED controls 3 LEDs, A, B, C. This board LED controls only 2 LEDs. So I choose to use board LED 2 so that I can save extra pin for any general purpose usage. However, you can easily choose this board and it will work using 3 LEDs. Okay, let's go back here to the notify. So here we choose the logic, the driver of these LEDs, which determines the logic, how many LEDs, the signals that I give using LEDs, the type of blinks that I use for different notification. And at last, we define as a buzzer. We just add this definition to the backend buzzer driver. So to define the board in the for the compiler, in order to build this board, you need to access some extra files. First file, okay, is this file, firmware version decoder. You just simply add your board and the number, and first you go to this board list.python, and again you define your board, and this is where this text is taken from. So if you write here XYZ, then you will be able to make XYZ board. Then you go to this file, boards.python, and in this file, go like that, open a clear view. Okay. In this file, it's simple. You can take any copy paste and it will work straightforward. You define your board name and you inherit from the Linux class. You define the tool chain. By the way, you can change this tool chain using wef command. If you compile using wef command, you can give it tool chain. I already used different tool chain for Raspberry 0 than Raspberry 4. Then you here you add the definition, the very first definition that you defined here that you defined here. This definition you add it to the environment definition, so it will, when the compiler run, it will execute the part of code that are surrounded by this definition. And that's it. Now you can add your board and define the same definitions. You go through the same files and you will have your board running. My advice is to study this file, because there are different boards here, and these boards have different definitions. Also, this file, this is a very important file. This file, as you see here, there are a lot of definitions, a lot of combination of sensors, so you can get an idea of what is possible and what is already there, and you can use some of this idea to create your board. Thank you. I hope this video is useful. Thank you very much.